formulas aspect. So to begin with, let us go ahead and look at the first question. This question says, which of the following correctly defines the relationship between variances of sample mean for simple random sample drawn with and without replacement? This is what the question is asking. In order to go ahead and do this question, I would like to first explain you what is with and without replacement. So have a look here. Now, just see here. See, when I talk about variances of sample and I'm talking about with replacement, this is how the sample mean looks. This is the usual formula that we have gone ahead and we have seen. So it is usually that the sample mean, it is normally distributed with mean mu and variance sigma square by n. So with replacement, the sample mean that we have is sigma square by n. Now let's talk about without replacement. When I talk about without replacement, we usually have something which is known as a correction factor, and that is known as finite population correction factor. That finite population correction factor, that is basically given by this n minus n upon n minus n, where capital N is for population and small n is for sample. So remember that whenever I talk about the with replacement part, with replacement, we will have a correction factor, and this correction factor is n minus n upon n minus 1. So in the variance of with replacement, you will go ahead and you will include this correction factor. Okay, so this is how the two will be different. Always remember, this is throughout. One will be without replacement and one will be with replacement. With replacement means what? That, you know, if I have a population and it has different x1, x2, x3 and so on till xn, I want to make a sample out of it. I can choose any one value and then I can choose that again. That is with replacement. That's with replacement. So with replacement is what has the variance sigma square by n, and without replacement, you're going to go ahead and you're going to include this finite population correction factor. Now, there are some notable features that you must want to go ahead and make a note of. First of all, whether I talk about the sample mean with replacement or without replacement, it is always an unbiased estimator of the population mean. So whether I talk about, please make a note, with or without replacement, the sample mean that you find out, this is an unbiased estimator of the population mean. That's the first part. Second part, with replacement, average variance of all possible outcome of sample is sigma square. So ye kya ho gaya? Ek bari dekh lo. See, when I say that so I am saying x bar is normally distributed with mean mu and variance sigma square by n. This is the variance of this. Now I want to ask, is this variance an unbiased variance? Is it an unbiased estimator of the variance of the population or not? So the answer is yes. If I find the expected value of sigma square by n, I will simply get sigma square of population. That means that this sigma square by n is an unbiased estimator of the sigma square of the population. So when I talk about with a replacement, I am saying that the sigma square by n, the variance that you find for x bar, It is an unbiased estimator of sigma square. Then we talk about what happens without replacement. Now, without replacement, what is the variance that I found out? Without replacement variance was sigma square by n, n minus n by n minus 1. This was without replacement. So I want to ask, is this an unbiased estimator? I'm just giving you all this extra information. You should remember this. Unbiased estimator of sigma square of population. The answer is no. It is an unbiased estimator of a different version of sigma square of population. Which sigma square? When the formula of sigma square is this. So please read this down. Average variance of all possible samples selected without replacement is equal to modified population variance. So the expected value of the variance of the sample which is without replacement, जो भी हमने formula निकाला, it is equal to this. It is equal to the modified population variance. Okay. Now let's go back to question after all this information. So we know that we have got two parts to it. The first part says that we understand that we have the variance of the sample mean with replacement, and that is given by sigma square by n. And we know that without replacement, it is given by sigma square by n, n minus n upon n minus 1. Now we just have to evaluate this factor एक बारी, क्योंकि ये वाला factor तो इससे multiply हुआ है. So what we can do is we can compare. Is n minus n greater than n minus 1? No. N minus n is less than n minus 1 because my sample size will always be greater than 1. So here I am subtracting n from it, and here I am only subtracting 1 from it. So n minus n will be always less than n minus 1. This implies that n minus n upon n minus 1 will be less than 1. So if I multiply sigma square by n on both sides, I will get this relationship number A. So we can say that the correct statement is A. Think about it. Tell me if there is any doubt. So we have got the sigma square of, we have got the variances in the two cases. The sigma square in the first case is sigma square by n, and the sigma square in the second case is sigma square by n into n minus n by n minus 1. And we have been able to prove that this is greater because this factor, this is less than 1. I hope this is clear to you. Okay. Now let's go to the second question. In hypothesis testing, which of the following defines the size of the power of the test? Now just think about it. We have learned two things. One is called type 1 error, and the other is called type 2 error. When I talk about type 1 error, type 1 error is basically alpha. And when I talk about type 2 error is basically beta. We have learned about both of these things. So if I just go back and I have to give you some brief about it, we have to understand that type 1 error is the probability of going ahead and rejecting null when true. And So Shomik, in case of standard deviation, we will just go ahead and take the under root of the variances. So it is just going to be this. Standard deviation will simply be this. Under root of the two things. But make sure that you understand that when I talk about these standard deviations and variances, these are for the mean. Please make sure that this is in your mind. My mean is normally distributed with sample mean is normally distributed with population mean mu and variance sigma square by n. So the standard deviation is sigma by root n in this case. So it's the same here. Sigma by root n, and this will be under root of this thing. Okay, fine. So let's go to this question then. So beta is the probability of accepting null when false. And when I talk about the power of the test is 1 minus beta. So this is the power of the test. So it is 1 minus probability of accepting null when false. Okay, come to the next question. So if you will notice, this question is again asking about with and without replacement. So again, you have to understand that the basic formulas are important from the exam point of view. Okay, so let me just explain you first, and then we will go to the question. Okay, Sudha. So in second question, we are just asking what is type 1 and type 2 error. And from there, we are going about the power of the test. So here, if you notice, type 1 error is called alpha, which is probability of rejecting null when true. And type 2 error is probability of accepting null when false. And power of test is 1 minus beta. So this is going to be this 1 minus probability of accepting null when false. This is your answer. Simply remember, power of the test is 1 minus beta. Okay, now come to the third question. Suppose that two random samples of size n1 and n2 are selected without replacement. So this is without replacement from two binomial population. This is the mean. So if you remember, the mean is always given by NP. So if it is population 1, then it will be N1P1 and population 2 will be N2P2. That is exactly what we have been given. N1P1 and N2P2. And the variance is given by NPQ, right? So it will be N1P1 1 minus P1 and N2P2 1 minus P2. These are the variances of the binomial population. Now we want to test the hypothesis testing P1 minus P2. So actually you can go to the refer to the notes that I have given you, and that also we have done this. But you know, we have always done with replacement. So with replacement, the formula of sigma 1 square is P1 Q1 by N1. And with replacement, the formula of sigma 2 square is P2 Q2 by N2. Please do not confuse yourself. We are testing proportions, differences. So when we test the difference in proportion, the formula for that, if you remember, if you go back to your notes, you will see it will be P1 minus P2 hat. Hat mane population wala. Or you can just put P1 and P2 and then put its expected value. So minus E of P1 minus E of P2. Upon the standard error of P1 plus standard error of P2 under root. And these not standard error of P1, P2 under root, but just variance of P1, P2 under root. You can write like that also. So variance of P1 plus variance of P2 under root. You can make it like that also. So basically, this is exactly what we are doing. Usually, this is what your denominator is. Your denominator is under root P1 Q1 by N1 plus under root P2 Q2 by N2. This is what usually we use for differences in the proportion. But because it is with replacement, without replacement, we will go ahead and we will use something which is known as a finite population correction factor. So in finite population correction factor, we will go ahead and we will have this factor. N1 minus N by N1 minus 1, N2 minus N2 by N2 minus 1. These would be my correction factors. Just like we did in the above question. Everywhere you see without replacement versus with replacement, you have to make sure that you include this correction factor. That's the only trick to these questions. So basically, this is exactly what this question is asking, and this is exactly what I have done. So because the question is asking without replacement, I have gone ahead and I have included this correction factor here, population correction factor here. This will be included everywhere. Wherever you do without replacement, this factor will come into picture. So the answer to this question is A. Come to the next question. See how easy questions have been asked in case of probability. Very, very simple questions have been asked. The probability of getting head in toss is 2 by 3. Let the coin be tossed 3 times independently. Then the probability of getting head in first 2 tosses and tail in the final toss is. So it is asking what is head, tail, tail. And these are independent. So it will be probability of head into probability of head into probability of tail. This is head, head, tail now. So 2 by 3 into 2 by 3 into 1 by 3. So this will be 4 by 27. So very simple question has been asked in probability. Therefore, basics are very, very important. Okay, come to the next question.